The subscript 0 is actually a standard math thing, and actually science, physics, and all that thing. When you see a subscript 0, it means an initial condition. So for the purposes of this, v sub 0 is the initial velocity of the object. When I throw it in the air, when it gets fired out of a gun, whatever. Initial velocity, h sub 0 is the initial height. So if you're following along, if I told you I had a projectile motion equation, h of t equals negative 16 t squared plus 80 t, what is the initial velocity? 80 feet per second, correct?
Oh, okay.
What is the initial height?
Assuming 0 or ground level.
The initial height is the constant right here, which is 0, which means it just gets launched from the ground. Straightforward? If we kind of went in reverse, and I said, I throw a ball straight up, with initial velocity of 80 feet per second, and from a height of 10 feet, find an equation for that information. What would the equation be? You're throwing a ball straight up, straight down, so it's a projectile motion equation, and you can just plug in the variables, right? Okay, so you would get h of t equals negative 16 t squared plus initial velocity, which is 80 t, plus initial height, which is 10, and there's your equation. Pretty straightforward? Okay. I have overtime on my video. Oh well. You should know this equation. You'll actually get practice with this on the homework. If you don't know the equation, well, you'll get practice with it on the homework and you'll learn it. The one good thing is, what type of equation is that? Quadratic, right? Which means, how are you generally going to solve it?
Quadratic formula.
It's a quadratic. So you'll solve it just like a quadratic. The fact that it's an application and it involves projectile motion is actually mathematically completely irrelevant. It's an equation, it's a quadratic. Solve it like normal. Different questions you can ask, and throughout the semester we'll actually repeatedly come back to that and look at quadratics in different ways and different applications. But suppose we have this right here. That's my projectile motion equation. I want to know when the ball hits the ground. What do you do?
Set it equal to 0.
Ultimately, you have t and h of t. Two variables, essentially. Time and height at a given time. Mathematically, I have to give you one and you find the other. If you want to know when it hits the ground, I have to give you the height. When it hits the ground, what height is it? 0. So, take your quadratic, set it equal to 0. I'm not actually going to solve this out, we don't have time. But it's a quadratic, set it equal to 0, done. Solve it. Quadratic formula. Hit enter on your calculator. You want to be a little bit more entertaining? When is the ball 20 feet off the ground? What do? Set the height equal to 20. Solve that. How do you solve it?
Quadratic formula.
Not yet. What do you do first?
Set it equal to 0.
Set it equal to 0. It's a quadratic, set it equal to 0. So subtract the 20 over here, quadratic formula, and you're done. How many answers would you get?
You should only get 2.
Assuming it's a projectile and it's going up and coming down. Again, I know that's not the actual path of the object, but whatever. How many times is it 20 feet off the ground?
Twice.
Assuming its maximum height is higher than 20 feet, it's actually 20 feet 2 times. So you get both solutions. One thing I will point out that will occur with this and with other quadratic applications, a lot of times you'll get two solutions. The first one, when it hits the ground, you'll get two solutions. How many of them do you want?
You only want the second
How many do you want?
one.
One, correct? First one or second one?
Whenever it hits the ground, not when you threw it out.
Second one, when it hits the ground, correct?
Oh, yeah.
If you launch it from the ground, it'll actually start right here. So you'll actually get the starting point and the ending point. Time equals 0. This one, you'll actually get a negative answer over here, which makes no sense in the real world anyway, a negative time. A lot of quadratic applications, you'll end up with negative solutions. That generally means those are wrong and you want the positive ones. Got it? Again, as we do more applications, that'll become more apparent. Any questions? Okay, good. Your homework's posted online. You guys online already have your homework posted and you know when it's due. You guys in class, I will see you on Monday.